Dear students, welcome to the lecture series on the topic Engineering Graphics. Today we are going to discuss about the applications of the auxiliary planes to evaluate the true shape and size of an inclined cut section surface which has been cut by an auxiliary inclined plane. I am Dr. IPS Ahuja, Professor, Department of Mechanical Engineering, Punjabi University, Patiala. Now here we have been provided with a solid which has been cut by an auxiliary inclined plane, leaving behind an inclined section cut surface at the top of the solid over here. So this is the inclined section cut surface of the solid. So as we observe this cut section surface of the solid, we find out that once we draw the front view of the solid, so this cut section will be appearing as an edge view in the front view construction of the orthographic projection. While we are looking at the solid from the top side, that is from above, so the view which will be obtained onto the horizontal plane. So this view will be showing us the shortened view or the reduced view of this particular cut section. The reason is because this cut section surface happens to be inclined to the horizontal plane, so the projection of this cut section surface onto the horizontal plane which will be obtained in the top view projection will be appearing as an apparent shape of this section. So that is why we are not able to see the true shape of the surface either in the front view. So the front view contains the edge view of the section surface, while the top view provides us with the shortened view or the apparent shape view of this section surface over here. So we are required to obtain the true shape and size of this particular cut section surface using the auxiliary plane method. So what we are going to do, first of all, we are going to plot the front view orthographic projections of the solid, wherein this edge view of the cut surface will be available with us. Then we will be plotting the top view projections of the solid, in which the apparent shape of this surface will be observed by the observer over there. And then we are going to draw an auxiliary inclined plane parallel to this surface. So an auxiliary inclined plane parallel to this surface will be drawn, and the projections of the different points of the section surface onto the auxiliary inclined plane will provide us with the true shape and size of this section surface over here. Now let us read out the statement. So we are required to draw the complete auxiliary view and also find out the true size and shape of the inclined surface which is provided to us in this figure given below. So we have been provided with the isometric projections of the solid which has been cut by an auxiliary inclined plane. So this is going to be the front view of the solid. So using this information, let us proceed with the construction of the orthographic front view and the top view projections of the solid. So as we observe the solid from the front side, so we observe that the width of the solid happens to be 56 millimeter, and we can divide the solid into two elements. Element number one, it is the base block which is having the dimensions height is equal to 20 millimeter and width is equal to 56 millimeter. Then you have this triangular surface which will be appearing to us in the front view, and over here it will be starting from the top point of the surface, starting from the left hand side, and the height of this inclined surface happens to be 40 millimeter. So this is the discussion regarding different elements which will be observed by the observer from the front view. So let us proceed with construction of the front view. So we know that the height of this base web over here, so this is element number one, which is the base block or the base web. So this is a horizontal web which is lying at the base of the solid. So this horizontal web, it is going to have the thickness is equal to 20 millimeter and the width it is equal to 56 millimeter. So I have drawn these two projection lines, this one and this one projection line at a distance of 56 millimeter. So this is the width of the solid and this is the height of element number 1. So with the construction of this rectangle, we are able to observe this particular surface of the solid from the front view. So this is the true shape of this rectangular surface which has been obtained onto the vertical plane in the front view projections over here. Then we have the surface number 2, which corresponds to the section portion of the solid. So this is a triangular surface where the first portion, that is on the left hand side, the starting point of this inclined surface, it is right here on the top surface of the web over here. And then the top point, it is lying at a height of 40 millimeter from the top surface of element number 1. So this is 20 millimeter. Now here I am going to mark 40 millimeter from the top of the surface. The moment I mark this distance of 40 millimeter from the top of the surface, I am able to obtain this edge of this edge view over here. So point number 1 of this edge view, it is lying over here. Point number 2 of the edge view, it is lying over here at a height of 40 millimeter from the top surface of the horizontal web which is given to us. Now this is the edge view of the solid as it appears to an observer who is looking at the solid from the front view in this direction over here. Now let us draw the top view. So we know that the top view, you can divide the solid into 3 parts. This is first rectangular surface which is lying on the back side. This is second rectangular surface. So even though this is an inclined surface, but on the top view, that is on the horizontal plane, we are going to observe this inclined bigger surface as a foreshortened or a reduced surface, which will give us the apparent shape of this bigger rectangular surface over there. And then we are going to get this third rectangular face over here. So these face number 1, face number 2, face number 3. So 3 rectangles will be visible to us in the top view as we are going to look at the solid from above. So we know that once again, this is the width. So width we have already plotted, it is equal to 56 millimeter. Now this depth of the solid, so we can divide it into 3 parts. The first segment, this is having the depth equal to 20 millimeter. Then the second, that is the inclined surface, it is having the depth equal to 40 millimeter. Then the third section, it is having the depth equal to 20 millimeter. So I have marked these 3 depths, 20 millimeter, 40 millimeter and 20 millimeter over here. Now I can draw horizontal lines corresponding to this portion. So this rear edge of the solid has been drawn over here. Then the second edge, this edge, it is corresponding to the section surface over here, that is edge number 2. So this I can plot it over here. Then this is the edge number 3 corresponding to the second edge of the section surface over here. So edge number 3 has been plotted. And finally we have this front edge of the solid over here, right? So this is the front edge or the edge number 4 which will be plotted over here. So with this we have completed the construction of the front view and the top view of this particular solid. Now let us darken the different elements or the edges which are visible to the observer. Now this is the front view projection, this is the top view projection. Now we are interested in obtaining the true shape of this section surface over here, which is appearing as an edge view in the front view. So this surface is corresponding to this inclined surface projections which we are able to find out into the top view. So we are not going to draw the complete auxiliary view projections over here. So we are going to draw the projections of the true shape of this inclined surface over here. So now we have marked these points. Point 1 corresponding to this corner, point 2 corresponding to this corner, point 3 corresponding to this corner, and point 4 corresponding to this corner. So we have shaded this section surface as it is appearing to us in this isometric projections over here. Now having drawn this section surface in the top view and mark different points over here in the top view. Next, we are going to mark these points in the front view. So as we look at this section surface from this side, from the front side over here, so what we are going to observe, projections corresponding to point 4 and 1. This is point 4, this is point 1. So projections corresponding to point 4 and 1 in the front view, they will be appearing as 4 dash and 1 dash over here. And similarly, projections corresponding to points 3 and 2. So this is point 3, this is point 2 over here. So projections corresponding to point 3 and 2, they appear as 3 dash and 2 dash over here. Now the edge view of this section surface has been obtained. Now we need to draw an auxiliary inclined plane which will be drawn parallel to this section surface, and this auxiliary inclined plane has been drawn over here. X1, Y1 is my auxiliary inclined plane. Now from these points over here which are appearing on the edge view, I have to draw the projector lines which will be perpendicular to the auxiliary inclined plane. So these two projector lines, they happen to be perpendicular to this auxiliary inclined plane, and the projection which will be obtained on the auxiliary inclined plane, that is the auxiliary plan projection. So the auxiliary plan projections which will be obtained over here, they will provide us with the true shape of this cut section which has been marked as 1, 2, 3, 4. Now in order to draw the auxiliary plan, now we need to evaluate the distance between points 1 and point 2 from the vertical plane. So please check, we have not marked this distance over here. So this distance was taken as an arbitrary distance in this particular case. So in order to evaluate the distance of point 1 from VP and point 2 from VP, we have marked this distance as distance X. Okay, so we have labeled this distance as distance X. So whatever is the distance of point 2 and point 1 from VP, so we are going to say that this distance is equal to distance X. Now this distance X I am going to mark in front of this auxiliary inclined plane alongside this projector, and alongside this projector also in front of the plane I am going to mark this distance over here. So the distance X has been marked in front of the auxiliary inclined plane, and then I am going to draw a projection line which will be parallel to this AIP, because this projection line, it is also parallel to this vertical plane, because the distance of point 1 and distance of point 2 from the vertical plane happens to be equal. So this point name which I have obtained over here, this will be 1, 1 corresponding to point 1, and this point name will be point 2, 1 which will be corresponding to this point number 2 over here. Now next we know that the distance between point 1 and point 4, similarly the distance between point 2 and point 3 happens to be 40 millimeter. Now I am going to mark another distance of 40 millimeter from this surface, that is in ahead of this dimension X. I have marked another length equal to 40 millimeter over here. So this is the depth of the solid which I have plotted. So starting from this point, the depth of the surface happens to be 40 millimeter. So this is the depth of this inclined surface. So we can see even in the isometric projections, we have been provided with the measurement of the depth of this particular cut section. So this depth 40 millimeter has been marked. After marking this, again another projection line parallel to x1 y1 or 1 1 2 1 will be drawn. Now why we have drawn a parallel line? Because the distance of point 4 from vertical plane and the distance of point 3 from the vertical plane, they happen to be equal. So once we have marked this distance X, now we are going to mark another 40 millimeter depth ahead of this distance X over here, so that we can obtain the point 3 1 and 4 1 over here. So this point 3 1 has been obtained at a distance of 40 plus X from this auxiliary inclined plane. So this is the distance of point 3, this is 40, plus x over here. Similarly, the distance of point 4 from the AIP, it will be equal to x plus 40 over here. So this way, all the 4 points of the section surface, they have been located in the auxiliary plane projection over here, which have been obtained onto the auxiliary plane. And now, since these projections, they have been obtained by virtue of drawing this auxiliary inclined plane parallel to this edge view, so the projections of this section surface onto this auxiliary plane will provide us with the true shape of this particular inclined section surface over here. So this is the inclined section surface and this is the true shape. Now we can observe that this surface, it is a shortened surface, whereas this surface, it is a bigger surface as compared to this apparent shape of the cut section. So this is the edge view of the cut section, this is the apparent view of the cut section, and this is the true shape of the cut section which has been shaded over here in the isometric projection. Now we can also shade this. So after you shade this, it means that we are talking about this cut section for which the true shape has been obtained in the auxiliary plane which has been developed onto the auxiliary inclined plane. So this is the complete discussion regarding the procedure to obtain the true shape and size of a section surface which has been cut by an auxiliary inclined plane. So this is all for today. So we'll be continuing with the discussion regarding few more cases and applications regarding the evaluation of the true shapes of the inclined cut section surfaces of the solids in the coming lectures. So thank you very much. Thanks a lot.